co-host, but I can give you permission to record.
Okay.
All right, so it should be recording now. Thank you, Amal.
Yes. Wait, Hamal, can you spotlight me? Or did she leave?
I think she left, but
Okay, that's okay. Everyone just pinned me like Tommy said. Okay. So, yes, today we are doing complex numbers. Does anyone already know what a complex number is or have some kind of background with it? I'll take that as a no. Okay, so that's why we have this section called, oh yes, awesome. So that's why we have this section called what is a complex number? And basically what a complex number is, it's this number in the form a plus bi, where I is going to be an imaginary number, which is the square root of -1. And typically this is referenced with the letter z. So you'll see something, like in the next section I wrote a plus bi, but typically people will just write z instead of that. So let's go through some vocab. Our first part is the real part, which is just a. So there's no I with it, so there's no imaginary number in that part of it. And that's basically all the real part is. And you'll see it's written as RE, and the answer is just A to that. And so back to that Z notation, sometimes instead of A plus BI, people will just write RE of Z. And now we have the imaginary part, which, like how the real part is A, the imaginary part is basically the coefficient of I. But just know it does not include I. So if I ask you for the imaginary part of like 2 plus 3i, the answer would be 3, not 3i. Okay, are we good so far? Everyone good? Yes, awesome. All right. So our next vocab word is complex conjugate. So like you can just read ahead and see, basically if we have a complex number in the form a plus bi, the complex conjugate is the negation of that b. So if it's a plus bi, it'd become a minus bi. If it was a minus bi, well then the complex conjugate would be a plus bi. And the reason that we discuss this is because multiplying a complex number by its conjugate will always result in a real number, so there won't be any I left over in the product. And the last important vocab word is the absolute value, the magnitude, the modulus. There's a bunch of different words for this, but what they all mean is that if you're writing out, if you're graphing the coordinate, or if you're graphing the complex number as a coordinate, which we'll discuss next, then all of these vocab words are talking about the distance from the origin to the point, which is why the value is the square root of a squared plus b squared, which if you just like, I can show you on the next picture, it just like using the Pythagorean theorem. So let's go on, argand plane. So the argand plane is the same thing as the complex plane, and it's basically like a graphing system for complex numbers. So you know how you'd usually have an x-axis horizontal and a y-axis vertical? Well, it's the same thing, but here we have a real axis, which is horizontal, and an imaginary axis. And if you were to graph a point, a plus bi, well then it'd basically be like pointing the coordinate a comma b. And here we have some pictures. I can't point on it, but you can see that here we have the real part horizontal and the imaginary part vertical, and here are all of our points with the numbers they correspond to. So if we go back to our magnitude, well, the magnitude of 2 plus 3i is the distance from our origin right in the middle to 2 comma 3 basically. And if we were to draw our right triangle, that's how we would get square root of a squared plus b squared. So, any questions yet? No questions? Awesome. Let's go on. Oh, section 2. Tommy, do you want to take over?
Yeah, sure. All right. So powers of I, as you guys know, we already went over this. I is the square root of -1. So I squared is going to be -1. And then I cubed is going to be I times I squared. So by that logic, it would be negative I. You can extend that and you can even go to I to the fourth is equal to 1. And now, because we've reached 1, what this is going to do is it's going to cycle. So once, basically, you have 1. So if I asked you what, for example, I to the power of 2022 is, what you could do is you know that it cycles every 4. So you could take the the power mod 4 of it, which is going to be 2, and you could just calculate I to the power of 2. So I raised to the power of 2022 is going to be equal to I to the power of 2, which is going to be equal to negative 1. And that's a pretty basic usage of it. We might go into like some more complicated.
Okay, awesome. Now into another section. I just got a question DM to me. Will we guys have access to this handout? That's a great question. I can actually post it on the Discord right now, and maybe we can host it on the website later.
And yeah, if you guys aren't in the Discord is a good thing to join. I can send you guys the invite for the Discord in the chat in a second. Continue.
Okay, so yes, let's go to operations with the complex numbers. So if we just start off with addition and subtraction, it's a lot like if you were doing this with like a binomial or any kind of polynomial where you group with the same coefficients. So a plus bi plus c plus di, you group the real parts, which is a and c. Oh, there is a typo there. That's okay. Wait. Yeah, okay, there's a typo that I'll fix later. That's okay. So yes, a plus bi plus c plus di would be a plus c plus b plus d times I. So just a little typo on the handout, but that's okay, we say it, is just grouping a and c and then grouping b and d. And it's the same for addition and subtraction because we know subtraction is just adding the negative. So now we can go on to multiplication. It's also a lot like polynomials, kind of like the foiling method is my preferred way for binomials, where if you have a plus bi times c plus di, you can basically say this the same as multiplying a plus bx times c plus dx. And we know that using FOIL, we have first, so you're going to group the first of each pair. So that's a times c, which is our term right here. Then the outside, so that'd be a times di, which is right here. Then inside, so bi times c, that would be right here. And then last, we have bi times di, which is bdi squared. But what did we say earlier about I squared? Well, it turns out that this I squared is actually negative 1, which is why this becomes AC minus BD. But then we still have our I's with the AD and BC. So altogether, this becomes AC minus BD plus AD plus BC times I. Okay, and last but not least of our operations, we're going to divide, which does get a little bit trickier because we want to rationalize the fraction here. So we know that multiplying by a conjugate of a complex number is going to give us a real number. And we also know that multiplying by 1 doesn't change a fraction. So if we have x over some complex number, we're going to multiply it by the conjugate over the conjugate. And when you do that, if we just use our multiplication rules right here, this a plus bi times a minus bi becomes a squared plus b squared. Okay, and then we also have our x times a minus bi, and that's just our numerator. So, any questions about this? None? All right, awesome. On to section 4. All right, Tommy, you want to take this one?
Yeah. So let's talk about the complex conjugate root theorem. So the complex conjugate root theorem states that uh, whenever there's a polynomial with all real coefficients, if we know that like there's one complex number that's one of the roots, then the conjugate of that complex number is also a root. So for example, what I mean by that, right, is let's say that I know I've got some polynomial with all real roots, and I found or somebody's told me that one of the roots is 1 plus 2i. Or sorry, they say 2 minus I in the particular case here. So basically when we say conjugate, we just mean like you take a plus bi and the conjugate is gonna be a minus bi. So over here, the conjugate is 2 plus bi, or sorry, 2 plus I. Um, and as it says here, you can verify this by just multiplying these two polynomials, and what you're gonna get is something that takes out the I or the other part completely. So when you eliminate that, you're gonna be fine. Also, by the complex conjugate root theorem, when a complex number is a root of a polynomial with all real coefficients, its conjugate is also a root, which is what I said. Now, I've always been bad at pronouncing this. Is it Descartes or Jesse? Do you know?
I like whenever there's a mathematician name, I always purposely mispronounce it so no one can correct me. But I think it is Descartes.
All right.
Descartes?
Okay.
I
So
don't know.
Descartes, he has a rule of signs, which can be used to determine the number of possible real roots of a polynomial, but it will not tell you what the roots are or the exact amount of real roots. So this polynomial x to the fourth minus 2x to the third minus 6x to the second, or is that second or third? Yeah, second, plus 22x minus 15. When we're gonna find the maximum number of real roots in this polynomial, we can count the number of sign changes between the coefficients. So the first coefficient is 1, positive 1. Second coefficient is negative. So that's one sign change. Now, if we look at the next thing, there's no sign changes. That's still 1. Now there's a new sign change between -6 and 22. So that's 2 sign changes. And then there's going to be a third sign change from positive 22 to -15. So there's 3 sign changes here. So basically, we've got 3, like, we can only have 3 positive real roots here. If it's any more than 3 positive real roots, then somebody's lying to you because it's not. So essentially what we have here is we just know that there's going to be 4 roots, right? So there's always going to be 4 roots because it's x to the fourth. The degree of the polynomial is 4. They're not necessarily distinct, but what this tells us is that we know that at least one of them is a negative real root. So again, you see, this tells us one sign change, and this doesn't tell us anything about really how many imaginary roots there could be, but it tells us that we've got maximum 3 positive real roots. So we're not going to have 2 positive real roots because the imaginary roots would come in pairs. So it's going to be 3 or 1 positive real root. Jesse, I didn't mess up there, right?
Oh, that's right.
All right. Yeah, that's right. Okay, so we've got a couple of practice problems written in the document, and then we've got a couple more that are off the document. So this first one, if you guys have never done infinite sequences, this might be a little bit of a challenge, but I'll explain it. So I'll give you guys a couple of minutes until 6:25, I guess, and you can DM me or Jesse once you have finished trying. And if you don't know how to, just say that and we can move on.
Okay, yes, the question will be disappeared for a second. Let me just put it back up. Okay, incoming. Here we go.
Yeah, so if you still have Jesse pinned, you'll be able to see that he magically put this problem above his head. I don't know how he did that, but
It's magic.
All right. Has everyone gotten a chance to take a stab at the problem? I'm going to take that as a resounding yes. So basically, there is this I'm not sure if it's a theorem or just a formula that says that Jesse, if you could just write this on your screen or whatever. Um, so the sum of an infinite series is equal to a over one minus r. Now what is a and what is r? So a over here is the first term of the sequence. Um, and r is going to be the common ratio. So when I say common ratio, I mean, so he's written a plus ar squared plus so on. And where it's given that the magnitude of r is less than one. So and he went over magnitude. Yeah, you went over magnitude, right?
Yeah, we went over magnitude of a complex number.
Okay, yeah. So basically we've got over here, we know that our A for this sequence is 1. And then our R is half I. So basically what we like the first thing to notice about this is that your is that we're dealing with a geometric sequence. So this is just how you deal with infinite geometric sequences that diverge. Or sorry, that converge. And when I say converge, I just mean that it the sum ends up being some finite number. So now going on looking at this, we've got 1 over 1 minus half I. So if you there were a couple of people that told me 1 over 1 minus half I. Or so now how we could do this is we need to conjugate the bottom of that, right? So what we're gonna do is we're gonna multiply the numerator at Jesse, you can write this out. So just write 1 over 1 minus half I. Or sorry, 1 minus no. 1 over and then the quantity 1 minus half I. So 1 minus half I is under the bar. So now in order to conjugate this, what we're gonna do is we're going to multiply both the numerator and the denominator by 1 plus 2i, or 1 plus 1 half I. And even with complex numbers, obviously, if you divide one number by the same number, you're going to have 1. So now we're basically just multiplying this number by 1. But what this will do is it'll make the denominator appropriate. So, for example, in geometry, you may have dealt with numbers that had square roots in their denominators and you had to rationalize them. This is the exact same thing. So now Jesse's just doing that algebra for us. And what he'll find is that on the denominator, we're going to get 1 plus 1 over 1/4. Because what happens is these squares come out and then you've got minus the square of 1 half I. And the square of 1 half I is going to be negative 1/4. So that minus and that minus will cancel, and you'll get 5/4 in your denominator. Your numerator, which here wait, let me your numerator is still 1 plus 1 half I. And what we can do is we can over 5 over 4, and now we can just multiply that whole thing by 4 over 5. And yeah, so now we have 4 plus 2i over 5. And I know that some of you guys said 1 over 1 minus half I, which you guys are correct. But this is the correct form to express that in. So everybody's right here. It's just that this is the best way to express that. And yeah. Now, if you look at the next question, I think, Jesse, do you want to explain this one? This is the AMC one.
Sure. Sounds good. All right, let me pull this up. Okay, before we move on, any questions about what Tom I just did? Because we are here to help, so if you have any questions, feel free to ask.
Feel free to send it to me in the chat, to everyone in the chat. If you can send it to me, just me if you don't want, I don't know. But I'll explain it regardless. I'll give you a chance. Okay. I guess all of you understand that, so I'll let Jessica have the floor.
Okay, awesome. So I'm going to ask you guys a bunch of questions as we go through this because I don't want to do it by myself. So,
Wait, sorry. Jason asked a question. Why did you not multiply the two together? What do you mean when you say that? The bottom. So, uh, the final answer is 4 plus 2i over 5. Yeah, you might be looking at the bottom right. Yeah, we reached the answer on the bottom. Yeah, thanks. Good luck. Not good luck, but good thing we got that clear.
okay, awesome. So let's go to this one. Get ready for me to ask you guys a bunch of questions, and let's do it. Okay, so we have a polynomial x to the fourth plus ax cubed plus bx squared plus cx plus d, and it has real coefficients. So basically what that means is that a, b, c, and d are all real numbers. Okay, well, we also know that f of 2i is equal to f of 2 plus I. So basically it means if you plug those values in for x, this, like, when you evaluate it, you'll get 0. So what is a plus b plus c plus d? All right, anyone know how we can start this? Any ideas at all? Rule of signs? Okay, that's a really good way of thinking. Plug in values and cancel, okay. All right, I'm seeing a lot of people say plug in 2i, and that's a great idea, but if you notice, look at the question. It says f of 2i. So basically what this means is that if you plug x into our polynomial here, then that's going to be equal to 0. That's kind of what this notation is. If we have f, so you can basically pretend that f means function, and in parentheses is whatever value you're going to plug in as x. So the question already tells us if we plug it in, we'll get 0. So it's a good start, but unfortunately it's not what we're going to want to do. Okay, so do you guys notice that it says right here, our highest power is 4? Does anyone know how many roots we're going to have? How many roots does this polynomial have? A root is the same as a solution, is the same as something that when you plug in, you're going to get 0. 4, yes, okay. So the reason that we have 4 is it's called the fundamental theorem of algebra, and basically the highest power that you get is going to be the most, like, the highest number of solutions you can have. That's all it means.
So basically when he says the number of solutions, that just means that, like, it's 4 not necessarily distinct solutions, right? So if you have like x squared minus 2x plus 1, that has a solution 1, but it has it twice. So that just means that it just means that we have 2 solutions, but they're not distinct. So yeah, he's just applying that theorem to a larger.
Yes. All right. Awesome. So we know that if we have 4 total, like, solutions, and the question is going to give us 2 of them. So we can write these in right here. 2i and 2 plus I. Does anyone know how we can find the other 2? This goes back to something that we mentioned in our handout. So if you guys have that pulled up, you can go back to it. But this was the complex conjugate root theorem. So basically, if 2i is a solution, well, then so is negative 2i. And the same thing applies with 2 plus I. So 2 plus I is a solution. So that means 2 minus I is also a solution. And look, we have 1, 2, 3, 4 solutions. Okay, so we know the 4 different values that when we plug into our polynomial will give us 0. Does anyone know how we can figure out what the coefficients of our polynomial are based on this? let me go to a new slide. X to the fourth plus ax cubed plus bx squared plus cx plus d. Okay, and we know that our roots, 2i, negative 2i. Let's see, what are the other two? 2 plus I, 2 minus I. Okay, we're getting lots of great answers in chat sent to me. So yes, the next thing we want to do is write out our factored form. So let me use a new color again. So basically what the factored form means is that if we have a polynomial, we can rewrite it as x minus some value times x minus another value 4 times. So if we write it as 4 different sets like this, then when we multiply it together, we're going to get this polynomial. And what you're going to put into these little blanks is the roots of our equation. Because you'll notice that if we have, say, x minus 2i, well, then when we plug 2i in for x, this pair is going to equal 0. So when we multiply them together, the entire thing is 0. So let's do this with everything. So that's x minus 2i. X minus negative 2i is x plus 2i. So let me just draw some arrows. All right, I'm going to write them below, but these are still going to be multiplied. So x minus 2 minus I. And lastly, x minus 2 plus I. So, in other words, this polynomial is the same thing as these 4 things multiplied together. So, once we got here, does anyone know how we can proceed? Any ideas at all? There's no shame if it's wrong. Okay, so all we have to do is multiply these out and get it. Oh, okay, so I see someone saying that we should test for the multiplicity, and that's a great idea, but we don't actually have to do that, because if you notice, by our fundamental theorem of algebra, we have exactly 4 roots, and we have 4 unique roots already. Okay, so now all we have to do is multiply these together. So x minus 2i, x plus 2i. Now I'm not going to use FOIL here, I'm going to use the box method. Alright, so if we do this, well, x times x is x squared. That's negative 2xi. That's 2xi. And here we have 2i times negative 2i, which in other words is 4. Notice this cancels out. So this times this is equal to x squared plus 4. Okay, now what we have to do is x minus 2i times x minus 2 plus I. So x minus 2 minus I, x minus 2 plus I. Move over, do our boxes again. It's going to be a little tough to see, but that's okay. Here we have x squared minus 2x, negative xi, negative 2x, 4, xi, negative 2i, 2i, and 1. So these two will cancel out. This and this will cancel out. And that leaves us with x squared minus 4x plus 5. Okay, there we go. So that's x squared minus 4x plus 5. And in other words, hang in with me. All right, x to the fourth plus ax cubed plus bx squared plus cx plus d is, well, it's just these two things multiplied together. So it's equal to x squared plus 4 times x squared minus 4x plus 5.
Also, guys, I understand that he's writing a lot of stuff down right now, but if you guys have any issue, just write a direct message to him or me, and we'll stop and explain.
Yeah, we will stop if you have any questions at any point. Okay, but our last step is just to multiply again. So x squared minus 4x plus 5. Let me move it so I'm not writing over myself. And here we go. X to the 4th, 4x squared, negative 4x cubed, negative 16x, 5x squared, and 20. So, in other words, here we go, we have x to the 4th plus ax cubed plus bx squared plus cx plus d is equal to x to the 4th minus 4x cubed plus 9x squared minus 16x plus 20. Okay, let me copy this for the, let's go back to our question. All right, don't forget, our question is, what is a plus b plus c plus d? Well, let's just match it up. Oh no. Okay, here we go. A is negative 4. So we want to find negative 4 plus b is 9. Okay. Negative 16x. That means c is negative 16. And d will be 20. All right. Well, negative 16, negative 4, and our 20 cancel out. So that leaves us with 9. Do we have any questions at all? How did you do the box method? Okay, that's a great question. Okay, so this is something for multiplying polynomials, and it's kind of the same as the FOIL method, just written in a different way. So, should we do it with a binomial or a trinomial?
Go for the
All right,
binomials.
Binomial? All right, awesome. So let's say that we have ax plus b times cx plus d, right? So we can do the FOIL method where we have ax times cx, ax times d, and all the way there. But I prefer to write it out like this. So we're going to make a 2 by 2 box. Here we have ax, here we have b, here we have cx, here we have d. And all you have to do is multiply the two things that go to each box. So this is acx squared, which is ax times cx. Now we have adx, ax times d. Here we have bcx, b times cx. And lastly, bd, just b times d. And now we group all like pairs. So that's ac x squared plus AD plus BC, x, because they both have x's in here, plus BD. That's the box method. It's a great way to multiply any polynomial by any other polynomial, and it gets kind of hard to do it at like really big ones, but it's my personal favorite way. So, any other questions? Okay, if not, there is another question. Tame, do you want to take that one? I can pull it up again.
Yeah, sure. Pull the next one. So, hey guys, I know that those first two questions, they may have seemed intimidating and like you may have not known the tricks to solve them. And that's just because like they extended past like the reach of like what we already had. Here, wait. So this one should be pretty simple. Find the magnitude of 5 plus 12i. I'm gonna give you guys a minute to solve that.
Okay, and while you guys are solving that, I'll answer a question I just got. The point of the box method is just to multiply polynomials. There's no like reason to use it over FOIL or whatever your other preferred method is. It's just another way of doing it.
All right. Yeah, guys, private message me the answer to the question when you get it. All right. Okay, so I'm seeing a lot of correct answers. I only see a couple of wrong answers, but I'm gonna go ahead and explain this. So, if you guys remember, there is an organ plane, which is just like the Cartesian plane, where instead of actual distances, what you've got, or instead of x and y coordinates, what you've got is on the x plane, you got real numbers, and on the y plane, you have imaginary numbers. So over here, if this is the origin, the point would be like 5 units to the right and then 12 units up. And they're asking you what the distance is from that to the origin. Now, I'm sure everyone here knows Pythagorean theorem. So this is basically the same thing. We just have 5 squared plus 12 squared. And we're going to take the square root of that. So just 13. Most of you got that. There were a couple of you got it wrong, but you guys corrected yourselves. So I'm assuming you guys understand. This one is on the simpler end. So hopefully there should be no issues. But if there are, stop me. Otherwise, we're going to go on to some more questions that Jesse found.
I did not realize I was muted. Okay. So if we're all good, does anyone have any questions about anything we've done so far today? We covered a lot of material that will show up on FAMATs during the year. So it's important to understand. Okay. If we don't have anything, I'm going to start pulling up some questions that I found on past January regionals. So these are straight out of FAMAT tests. All right, let's start with this question. It's really similar to what you guys just did, but it's more, well, it's FAMAT style, I guess you can call it. It's got multiple choice. It's written how a FAMAT would be written, and it's just a FAMAT question. So I'll give you guys a little bit to send answers. I'm already starting to get some, which is great. And let's see. Okay, awesome.
So I got a question, a good question from, or well, I'm not gonna say his name was, but is the absolute value of a complex number the same as the absolute value of a real number? And the important distinction here is that over here, this is not called an absolute value, and you shouldn't think of it like that, because then that'll get you confused, and you're gonna try to make these like negative and like positive or whatever. That's not what it is. They're fundamentally different concepts. But what you can imagine it as is they're actually very similar, but if you think about it the right way, they are fundamentally different. So the absolute value is, you have the number line, right? And let's say that this is our number and this is the origin. The absolute value tells us the distance of the number from the origin. And then the absolute value, or the magnitude of a complex number, which you don't call it an absolute value, you just call it a complex number. It tells us the distance of that to the origin. So that's just what that means. And as long as you think about it, like the distance from the origin, you won't get confused. And make sure that if you're talking out loud, you say the magnitude when you're talking about a complex number. Otherwise, somebody might tell you you're wrong, which technically not. But go on.
Okay, yes, awesome. It does, like, another way you could think about it is that a real number is technically a complex number. Any real number is just like, say we have a real number x. Well, you can always think about it as the complex number as plus 0i. So that's just one way to get to the exact same thing. It'd be square root x squared plus 0 squared, which is just x. So that's another way you could think of, like, kind of similar, like similarities between the two. But back to the question. Okay. So I've gotten people saying B, C, and D. Okay. So what I actually like about this question is that the 2 is negative. But let's just like focus on our definition. Oh, I don't know why I deleted this. Okay, our definition is just the distance from the origin, and it doesn't matter if it's negative or not, because say we have a point here and then a point here that are like, it's the negative of it, but the distance to the origin is the exact same. So if we have 3, so it's going to be, let's say 3 units here, negative 2 units here, it's a 2, not a 3, right? So our coordinate would basically be right here. What we're finding is the distance. So what we have to do is, let's make a square, or let's make a right triangle, right? We got our 3 there, a 2 there. So 3, 2, and a hypotenuse. Well, Pythagorean theorem tells us that x is the square root of 2 squared plus 3 squared, which is going to be the square root of 13, which is option D. So I know some people had different answers before. Does anyone have any questions on why it's not the answer choice they thought, or how they can do something differently? Okay, if not, I will let Tommy take away on the next one. Let's start with this. No, I think you're muted.
Oh, sorry. I'll give you guys a couple of minutes. You guys can text me the answer through direct messages. Once enough of you are done, or I guess by 6:55, I'll go on and I'll explain it. All right. Somebody asked me, how often will these meetings be held? These meetings will be held every month. At least that's the plan for now. This is sort of a test meeting. We're gonna see how this goes. And once you guys are done, I'm gonna send that form in the thing again, and it says questions or comments. So you guys can just fill in any comments you had about this, or like, and we can just get to know how we could be helping you guys better. Okay. Most of you guys have given me the answer. I'm going to go over it anyway. So Jesse, just write down the fraction as it's written. So 1 minus 2i over 3 plus 4i. And over here, what standard form means is just rationalized denominator, or not rationalized denominator, but like conjugate. You multiply by the conjugate, right? And when we multiply by the conjugate, we only multiply by the conjugate of the denominator, because the denominator's conjugate is what matters here. Because we're trying to get the I term out of the denominator. That's the general goal of what we're doing here. So basically we're multiplying by the conjugate over the conjugate, which just means we're multiplying by 1. But what this does is it gets that term out for us. So you can see he's writing those terms out on the top. And basically you got a plus b times a minus b, which gives us a squared minus b squared on the bottom, which is what helps us get rid of that that conjugate. So the denominator is going to be 25, and then the numerator is going to be what? 3 minus 6i minus 4i minus 8. So yeah. I'll give them a second. All right. So yeah, that gives us the answer C, which is what all of you guys got. So good job, guys. Yeah. We can move on to the next question.
All right, awesome. Okay, the next one's a very nice question, if I do say so myself. I'm just saying that because why not? I have not actually tried to do it yet. What you are seeing is us live solving, which is the power of doing FAMAT for a few years.
We have not really seen these questions. We're just doing them.
Yeah, it's fun, because why not? All right, 5i times 2i minus 3 over 2 minus I minus 3i minus 2. I'll give you guys a minute to do it, because this one's kind of a lot, and let me know what you got. Okay, I haven't gotten any messages yet, so I'm guessing you guys are still working. I'll give you guys another minute, and then we'll start going over it. Okay, awesome. Answers just started to come in. So I'm gonna start going over it, but if you guys are still working, don't stop, keep working, and as soon as you get the answer, send it to me. So, let's start. So, there's actually...
I'm noticing that some of you sent the answer to me. Make sure you just send it to us.
Yes. Okay, so I'm getting a mix of C's and E's. So, I actually really hate when the answer is C, but let's see what we get. So let's start by rationalizing the first one. So 2i minus 3 over 2 minus I. Just a reminder, we'll multiply it by 2 plus I. And there we go, 2 minus I, no, 2 plus I, my bad. Okay, we're multiplying by that. So then we would get, that would be 4 plus 1, because remember it's going to be a squared plus b squared. And then if we multiply the top, 2i minus 3 times 2 plus I, that would give us 4i, negative 2, let me draw in our box. Okay, negative 6, and negative 3i. So then we have this here, let's just move it over here. This is the same as I minus 8 over 5. Okay, great. It's a little hard to see, but that's what it says. Let's go on. 3i minus 2 over 2 plus I. Well, we want to multiply by the conjugate again. So just notice that's the exact same things being multiplied together. So the the denominator will be 5. And we're going to multiply 3i minus 2 and 2 minus I. That's 6i, negative 4. Oh, let me draw my box. 2i, and lastly 3. So this is negative 1 plus 8i. And if we go back at the top, we're going to be subtracting this. So it's I minus 8 minus negative 1 plus 8i all over 5. Let's switch colors and scroll down. This is going to be, well, negative 8 minus negative 1. That'll be negative 7 minus 7i. Because notice right here, I minus 8i, that's negative 7i over 5. But we're not done yet, we're multiplying by 5i. So 5i times all this. Our 5's will cancel. That leaves us with negative 7i minus 7i squared. But I squared is negative 1. So negative 7i plus 7, or 7 minus 7i. That's our answer. And let's see, did anyone send that to me in chat? I think they did. Ooh, I got someone say 7 minus 9i. Let's see. Oh, well, actually, I'm getting option C. So I know a bunch of people did that. Some people got E instead. So did anyone else who got E get 7 minus 9i? Oh, messed up part of the calculation. All right, that's okay. So yes, our answer should be option C. All right, any questions at all about anything?
All right, we're gonna do one more problem together, and then that'll be it for this session. So yeah, Jesse, you can put up the next question. And Jesse, somebody asked me in the chat earlier where they'll be able to find these problems. So we're just gonna put all these problems into the handout, so that way when we send them out, you guys will be able to have access.
Yes, no. I know the website's down, so I'll probably put in our own solutions on there too, so you guys can see that there. But a improved handout will be out tonight. Okay, we have 5 questions left to choose from. Does anyone want to give me a random number 1 through 5? Okay, 2 was the one I got first. Ooh, this is the harder one.
Okay, somebody really wanted 3.
Oh, okay, so 3, okay. We'll go to 3 and tell me an easy one. Okay.
All right, so we're told that I is equal to the square root of negative 1, which we already knew. So we've got I raised to the 2021 plus I raised to the 2020 plus I raised to the 2019. So now what we can do is we can break down each of these into basically I raised to the power of like whatever that number is mod 4. So we can rewrite this as we're going to rewrite this as I raised to the power of 1 plus I raised to the power of 0 plus I raised to the power of 3. And if you guys are forgetting why I did that or why I was able to do that, then it's in the handout, and you can just review that in a bit. And it's basically just because these values cycle. So when basically I'm just going to rewrite the numerator first. So we have I plus 1 plus I cubed. Now what's I cubed? I cubed is going to be negative I, and that's because you've got I squared, which is negative 1, and then you're going to multiply that by another I, and that's going to be negative I. So we have I plus 1 minus I over I plus 1. Now we have to conjugate this. So what we're going to do is not conjugate this. We're just going to multiply by the conjugate, which is equal to I minus 1 over I minus 1. So now I minus 1 is our numerator, and our denominator is going to be I plus 1 times I minus 1. And a squared minus b squared. So what we end up with is 1 plus 1. And you guys are pretty smart. So 1 plus 1 is obviously 2. So we've got a. All right. That's our last question for the day. I hope you guys enjoyed that. Feel free to let me send you guys the link to that form again. Oh, Himal just sent that out for some reason. Wow.
She's reading your mind.
Yeah, she's reading my mind. I'm going to send out the form again. So now all of you should have filled it out by now anyway, but if you've got, I think you should be able to if you 1 second. You should just be able to edit your response and just say any comments that you have. We're just gonna use those comments to make September's session a lot better for you guys. And anyway, we hope you learned a lot from this. The conjugate, so it could be I plus 1 or I minus 1, but the funny thing is that it doesn't matter, because what you're doing is you're multiplying by 1 anyway in the end. So like technically it could have 2 conjugates, but you end up multiplying by the same thing. And you are right that if you take it from a plus bi form to a minus bi, then it would be 1 minus I. I just wrote it like that because it was in that form already. Good catch. All right, you guys are free to leave now after you guys give me some feedback, Jesse some feedback. And yeah, hope to see you guys next month.
Yeah, thanks for coming, everyone.
Hi, Theta teacher Tumne.
Hi. That went well. Oh wait, there's people here.
Did people follow you? What is happening? Did
I
all the
told them-
breakout rooms?
Oh yeah, you guys can go ahead and leave now.
Oh yeah. Follow the Insta at FAMAT students.
Yeah.
Yeah, if anyone wants to know anything about FAMAT, I'm happy to talk about that.
Yeah, you guys can ask any questions now. Earlier was any math questions. You guys can ask us questions about life. No questions about life. You guys already know everything. I mean, I guess one is your 7-year-old brother, so I'm assuming he knows everything.
Yeah, so you guys can feel free to leave the meeting, or if you want to check out the Moo session, you can do that.
Oh wait,
as
I'm gonna
well.
go over to the new session. Here, wait 1 second.